All right, I think you can hear me. So welcome everybody, good afternoon. My name is Markus. I'm here today with Alexey, my tech lead on the project. I'm the co-founder of Starfish. You've met my lovely wife at the opening ceremony yesterday. So I'm the second half of the company, doing mainly the tech stuff in here. And as you've seen in the title of the presentation, we want to share some insights we've been working on since a couple of months now, which is our journey on the programmable infrastructure we're working on, and this connects very nicely to what Chris was telling in the morning. So our take on serverless starts with a little intro I want to give to the company and the product we're working on, because that gives us context for what we are. So Starfish is a company which is fully remote since a couple of years. So we are on the market more than 10 years. We are in 19 countries with a very diverse, very lovely stuff, highly talented people. We are headquartered in Germany. We have a subsidiary in Portugal and Spain, and operate from here throughout the entire world with our services. And services mean services applied to a specific industry. In our case, it's payment, banking, fintech, and connected services. Like connected to that, and specifically there's one industry we're interested in is automotive. Like we do a lot in automotive, so in-car payments for instance, or any other complicated payment topic in that industry. And to accelerate these kind of projects with our customers, because we don't want to start from scratch all the time, right? We invented or developed our product called Hellgate. Hellgate is a payment orchestration, facilitation platform you can think of. It sits between what you have on the e-commerce side, so it's not made for point of sales, it's made for e-commerce, and sits on the bottom end. You see it with the payment service providers that you probably know, like a Stripe, Adyen, but also banks like HSBC, Deutsche Bank, JP Morgan, whatnot, pay you, a wide variety. And in this stack, our product is slightly different to what you would assume from a SaaS company. You typically run it as a product on your premises, or on your cloud. So you're gonna get it at a completely different licensing model that is typically common in this industry. And you see on the right, on the right to the Hellgate block, that dark black thing with the horns, you've probably also seen on our booth, we have that extension part. And I want to talk about that extension part now a bit more in detail before I hand over to Alexey, who will walk us through how we solve that puzzle. So, serverless, Lambda calculus, all of that stuff. And we've had a great opening keynote today about serverless, and Chris McCott made a very good introduction to how Flame solves a certain aspect of that problem space, right? But to be all very clear, and we've seen it this morning as well, and to be fair, actually, there is no serverless. Like, this is, actually, there's a computer somehow. It's maybe somebody else's computer, but like no computer, this is like a marketing claim that we are gonna find out in industry. And what we kind of interpret, or how we interpret it, it's actually a change to what we call the abstraction level of infrastructure that you've seen this morning. You open a Flame, you send your code somewhere, it's going to be handled, you don't have to worry about it in the programming model you're in, right? On the other hand, it's changing the way you do computation, the way you interact with your frameworks and whatnot. So this is how we kind of define the serverless term, and this gives us actually two sides of the coin that you need to solve to provide a service like Lambda or Azure Functions or something like that. You need to have elasticity and scale, one side. On the other side, you need to have a restricted runtime. And this is what we don't see too often in the talks in the industry out there. We have a very nice solution for elastic scale. Like we have had the introduction again this morning, so you don't have to worry about where or how to run the code you have. This is giving you great flexibility, an awesome product or framework that we have. On the other side, we need to have a restricted runtime if you think it like the full stack that you need to solve for serverless. And this is where we are working on. So you want to see in our presentation, we're scratching the surface of our ideas, but we want to propose something where you don't have to worry about the code you run. And this is very important if you consider one thing, and this is what I want to highlight with our stack that I'd recently shown. If you look at this picture, right, we have, we use a Flame and whatnot in the black box to orchestrate the code we have. But in our industry, we have a need for highly customization, like high adoption to specific needs. So integrating a new bank into the stack, integrating a new channel into the stack. This typically requires coding, programming, adoption of the system. And that's where we currently use serverless. in the extensions. In that extensions, we're currently running our services on Azure Functions, on AWS Lambda, DigitalOcean Function, you name it. We use that technology, and it's not bad. It solves the problem for us. We can extend our product with features and feature sets that we need, right? We can augment it in a certain way, but as we all love our platform Beam and Elixir and the ecosystem around it, we thought there must be a way to go deeper than that. And you do see the problem with restricted runtimes environment. If we're gonna get code that we run on our platform, maybe that's coming from our customers, like AWS adopts customer code, right? We need to make sure it's running in boundaries that are controlled. So this is where we are working on. This is where I also like to hand over like the list of wishes we both sat down like half a year ago that we want to have, how we can use the Beam as one joint platform to run hosted code from third parties, from our customers, using the elasticity of scale, on the other side having a restricted runtime environment. So that gives us very low incremental cost. This is a core driver of our business model. We can adapt very quickly to customer needs, and this is where we want to use the Beam. And Beam is a great platform. It has awesome capabilities, so we now need to understand what we can put to the equation to make that happen. And we need to maintain those boundaries in isolation, so it must be separated. On the one side, we need to have a way to execute those functions. Well, we've seen it in the morning. There's nice ways to do such stuff. We need to have a shared cluster between hosted code and platform code from us, hosted code from the customers. We all know the Beam OTP Elixir world is pretty much boundary-less to the inside, so there's quite some complication here. We want to establish well-defined interfaces, of course, because our APIs are used and augmented by our customers with behaviors. We want to provide a stellar developer experience because we want to give something to our clients, customers, and developers we're working with, which makes sense. Support all the Beam languages that are out there, and combine, of course, with frameworks like Flame to kind of get something like elasticity at the end and leverage the Beam to its full extent. So this was the wish list. We sat down and said, like, we want to solve all of that with our approach. There's a lot in the Beam that we can already use. And now we're going to jump into Alexey's part where he's going to introduce us to how what we call restricted runtime environment on the Beam could look like to add to the elasticity, also like the restrictedness that you need to have like really serverless on the Beam natively. That's where I hand over to you, Alexey.
Okay, the challenge is to run Elixir code from the source we do not trust. So how we can do it? First of all, we took a look at the Beam platform itself and look what does the Beam platform can offer us. Actually, it cannot offer us much. Traditionally, Beam platform was designed to work in a very trusted environment. And actually, there is nothing special here what you can do. So actually, basically, there is everything you can do inside the Beam platform. There were some attempts to build kind of safe Erlang like 20 years ago, but nothing we can actually use today. So next step is to take a look at OS level, and actually it doesn't offer much here as well. We can restrict network access, we can restrict file system access, and maybe something else, but not at this level of granularity we need. So yeah, we wrote it to another direction. So AST analysis is the second option we considered. And here is actually Beam platform can offer us something. It can help us because of this long history of Erlang and Elixir manipulating with different code representation. We can do something, but there can be some complications as well. So to get the AST, we need first to compile code, and Elixir compile time is very powerful. And when you are building restricted environment, every powerful feature is not cool anymore. It's dangerous. Yeah, and Elixir compile time is very dangerous. So here is a sample. This code runs a backdoor on your machine during compile time. So look how simple it is, how easy it could be. So you see here the network access, the file system access. You can run even Ruby during the Elixir compile time. Yeah, and all this happens during the compile time, and it looks terrifying to me. Yeah, especially Ruby. Ruby is terrifying. Just kidding. I like Ruby. No worries. So, yeah. What can we do with this? First thought was to use these OS level restrictions for file system and network. But there is another way. We consider the Elixir compilation is not safe operation, and we want to try to avoid it to run on our own machines completely. So we can require our users to compile their code. So it can help us to circumvent these security risks. And this decision has a very important consequence. Still, since we need to provide some tool for users to generate the code in the format we can safely analyze, or we have a chance to transform what was merely an API to some significant developer tool that can enhance developer experience, make developer lives happier with some generators, useful mix tasks, mocks, and whatever it could be. Okay, and now we need to decide what exact code representation we should pick. And there is quite some in the menu. So we considered 3 of them: Elixir abstract code, Erlang abstract code, and core Erlang. So Elixir AST and Erlang AST essentially are the same. The only difference that Elixir abstract code has some extra stuff which is required for other Elixir code during compile time, such as macros definitions, struct definitions, protocol definitions, and so on. And we actually do not need them because they are only required during compile time, and we are focused on the runtime. Core Erlang could be a good option because it is essentially a simplified Erlang, but as we discovered, the core Erlang AST could be more complicated than just Erlang AST. And it's so undocumented and so unknown territory, so we give up very quickly. So at the end of the day, Erlang abstract code is the most straightforward and convenient format to analyze. Yeah, and experienced Erlang developers know because how convenient it is, because this is the exact format that Erlang parse transform uses. And as a side effect, we have a support for other Beam languages for free. I tried Erlang and LFE, Lisp flavored Erlang, and it worked out of the box. So I'm not sure somebody will use it, but it's still cool. Yeah. How how can we extract this information? How we can get it? So one way is to extract the debug information from the debug information chunk from the compiled Erlang, compiled Beam file. And yeah, the compiled Beam file consists of several chunks, and maybe debug information is the most famous one because you may need sometimes to encrypt it or remove it completely, not to expose the source code at your production environment for security reasons, for example. Yeah, it contains exactly what we need, an abstract code. Elixir debug information has different format, but still it can be easily be extracted in Erlang extract code format. Okay, we have three-step process: packaging, analyzing, and execution. As I mentioned earlier, packaging happens on your machine, and the next two steps on our machines for security reasons. So yeah, the packaging. As you see, it's pretty simple, pretty straightforward code. One interesting thing I can mention is that debug information chunk is Erlang to binary encoded, and we transfer it via the wire, and we need to decode it on the server, and it could be potential remote code execution. So you need to be careful here. So analyzing step becomes simple as well because we already have abstract code in the format we need and which can be safely analyzed. Right now, we check only function calls against the predefined whitelisted functions. But in the future, we can improve those checks if we need. So there is a huge room for improvement and more fine-grained analysis. Yeah, and execution part may be the most interesting, and so we have a lot of doubts during the discussion. Is it really possible to run abstract code? It should be possible in theory, but we never did it. And as we discovered, it's pretty simple stuff to do, pretty easy. You see, we use here the very private internal function from Elixir compiler. And if you think about it, it makes a lot of sense because we have half compiled code and we need to compile it completely. So we have to use this internal stuff. But still, it's very simple, and we can use just Erlang API if something changes in the future in the internal Elixir API, Elixir compiler API. So that's basically it from my side. So yeah.
Right. Wait. Clear. So you see, like, we could only scratch the surface, of course. Like 30 minutes is a very short period of time. We would love to have done a demo today, but it's not possible. So if you want to learn more, bump into our booth, contact us about that. And you would probably wonder, like, why do you use that? Why do you need that, right? And a very typical use case I want to quickly mention to you, just to give you a little more context. Like, we work in payments industry. We look a lot of the card data. The card data is under specific rules of PCI DSS you probably heard about. You're not allowed to store it on your machines, not allowed to process it on your machines if you're not certified to do so, right? So our services take care of storing it compliantly, handling it compliantly. You could think of it like the Stripe card forms to get the data safely in our machine. But then you guys want to do something with that card data. Yeah, you want to send it somewhere, you want to transform it, you want to kind of do some analysis on that, right? And the way we do it is with our extension. So you write the code you want to use to do the job on the data, you give it to us, and we run it for you in our compliance parameter. That this gives you the ability to program on our infrastructure against the data that you stored, which is stored securely in our infrastructure, and you can do the transformation you need. Right? This is one of the main use cases what we have, that we use it for some very big companies out there. But this is just, as I said, a snowflake on the tip of the iceberg in the payments world. There are much more use cases, and this is something where we can highly recommend. If you're in payments, if you use Elixir, consider our platform as your payment augmentation tooling. With the QR code, you can get to the page, sign up for it. It's the sandbox is free of charge. You're going to get state-of-the-art merchant integration, so card forms for web, Android, iOS, cars. If you're programming for cars, we have an API SDK for cars as well. You get compliance, as I said, as a service, conditional payment processing. You can do A/B testing with the payments. You can, with that, do what a lot of companies, even specifically if they scaled up, you can unlock your data from your payment service provider. Because if you have the card data with Stripe or Adyen or whatever, it's there. It's very hard to get it out. It's precious customer information. We can help to unlock it. So sign up on Hellgate.io. It'll be something that is very helpful. We roll out a lot of features down the road, and that's up next for us. These extensions are currently private beta. We don't offer it free to the community, but they will get GA at the end of the summer. So you can start to program against the data that we have on our system or the abilities that we have on our system. And this is something we're really excited about to share with you. Also, towards the end of the year, the framework that we use to make all of that happen, we're going to open source. We don't have a name for it yet. We're going to open source that second side of the serverless equation, right? So you have like elasticity with Flame, with some name to be found. You're going to get the restricted runtime environments that you need to do serverless in your platforms if you have encountered the same question, like, is there code you want to run for your customers? If you have something you want to extend your system on where you don't want to put it into the core like a configuration, if you have code like configuration, this is something that can be very, very helpful for you. And that brings me to the end. We want to thank you for listening, for being here, and listening to our story.
Thank you, Markus and Alexey. So we have a couple of questions on Hoover. I think we have a few minutes. First question is, how do you manage extension versioning? Like the versioning, new.
Well, that's the cool thing is it's like the extension is config. You know, you can actually write it into a database if you want, actually. And with that, also have the ability to version it, to lock it, to trace it, whatnot, right? We move code into data config, and by that have splendid versioning opportunities. On the platform, it's like that. If you have used an extension on data, we're going to store it. If you update it, you're going to have new versions of it, but we're going to drop them for data compliance reasons and data security reasons until you use it again, because then we have to prove that you used it on the compliant data. So this is the way we do it in the platform.
Awesome. And we have a second question. Is it not too risky to not have a true sandbox environment for extension execution?
You want to take that?
I don't get the question.
Yeah, double negatives, it's a bit hard. Is it not too risky to not have a true sandbox environment for extension execution?
Two sandbox?
To not have a sandbox environment.
Have sandbox.
Maybe I can give it a start and you can comment on that. Like, a true sandbox environment is by no question more secure, and maybe also like the harder answer to the question, right? And this is technically possible. You could just have another cluster which is separated from like precious information that you have that still uses that technology to get like the code that you want to run in there, right? The use cases we have and the analysis that we put on top of the data is pretty sturdy. It's really hard to get something in our system which is like bad code, because we kind of do a lot of good work, in my opinion, to kind of strip it out. And with that, we kind of optimized actually the optimization problem, basically, between sturdiness of the restricted runtime environment and the ease of use, having it on the same platform. Because the arguments that Chris was using this morning, being on the same platform, being in the same cluster, more or less, also pays off here. Right? You can offer a lot of functionality which you couldn't if you have it in separated systems. You would need interfaces and whatnot.
Yeah.
I agree.
So we still have a couple of minutes. Any question on the room here?
There's one question.
Oh, sorry.
Thank you for the presentation, very interesting. I'd like to know what will happen if I will build a binary which will then be converted through binary to term on your machine already, because it will be safe functions, it will build binary, I will build binary with these functions, and we'll try to transform it to a function from binary.
Why do you think that it's safe function?
I don't know.
No, it's not.
It's. I mean,
No.
yeah. You probably you have a wide list of functions.
Yes.
I don't know. Of course, I don't know
Yeah.
what the list, but probably you can concatenate strings, right?
Yes.
There, for example. And I can build strings from, I don't know, from anything.
Yes, but you cannot do the binary to term.
Yeah. Okay. So
Binary to term you cannot do.
Okay.
So you will have just binary.
So we have to take our analysis job very serious.
Awesome. Another question just popped up on Hoover, and is, how can your customers test their integrated codes?
Okay, so this is something which is going into our product. This is what we said in private beta. The tooling that you get on the client side includes like a virtualization of what you get in the server side. So you're going to have fully testable code against like mocked interfaces to stuff that you're going to use later on the system. With that, you have the ability to run local unit tests, integration tests against the system, right? You can also kind of add up to that. Like we want to keep it as intentionally open to add more like abilities to that. And that gives you a chance to run stuff on your local machine. And then, of course, extend the testing lifecycle to our machines on the sandbox to then run it against real information that's stored on our services. But this is like the way we also think about the tooling that you need as a developer, and this is coming from the frustration we had using the tooling for the other tools we use like Lambda and whatnot. It is really difficult to get like a connected lifecycle of software engineering, considering extensions like as a function from the outside.
Awesome. So thank you, Markus and Alexey again. So big round of applause to them, please.
Thank you.